Hi everyone, we're on to chapter 6. This is the most famous of the continuous distributions called the normal distribution. When you think about SAT scores or people's heights, things like that, those are more than likely going to be normal distributions. All right, like if you say the mean height of a man in the US is 5'9", let's say. So you got this going on down here where you have the mean, say that's 5'9", and then you got people taller than 5'9", and finally get the really tall people, and not many of them. That's why there's not much under the curve, and you have really smaller people over here. Once again, not many of them, so not much going on down there. Okay, so the normal distribution is a continuous distribution. The notation x squiggly big N with a mu comma sigma. Mu is the mean, sigma is the standard deviation. The shape is a bell that has symmetry. Okay, the first one, the standard deviation, sigma here, is bigger than this one over here. So the data is wider in the first shape than the second shape. All right, so for small values of sigma, the bell is taller and more narrow. The probability distribution function is this nasty thing right here, but you don't have to worry about that really, because that if we were doing this from the calculus standpoint, then yeah, you would worry about that, and then you'd be finding areas under curves and using that f of x nasty thing right there. But don't worry about that. We're going to use a calculator to calculate probabilities. Okay, so the empirical rule, and we may have gone over this a little bit before, but you have this bell curve here, and you have the mean, mu is right in the middle. The mean and the median actually end up being the same for a normal distribution. Okay, so you have the mean, within one standard deviation of the mean, 68% of the data lies. So suppose the mean height is 5'9" with a standard deviation of 2 inches. So between 5'7" and 5'11", 68% of the population would be between those two heights. So that's what that's trying to say. 95% of the population is within 2 standard deviations of the mean. All right, 2 inches probably isn't a good standard deviation, but let's say it's 3 inches. So 5'9" minus 2 standard deviations would be 5'3", up to what? 5'9", 6'3". So 95% of the population is between 5'3" and 6'3". Okay, and then within 3 standard deviations, 99.7% of the data is going to lie within 3 standard deviations of that mean. Okay, so that's the empirical rule. The whole normal distribution is built on those 3 things right there. So let's do an example. Suppose x is a random variable that's normally distributed with a mean of 25 and a standard deviation of 5. So as you can see, the 25 right there, there's your mean, okay? The standard deviation is 5, so I subtract 5, I got 20, add 5, I got 30. So that means 68% of the data is between 20 and 30. And then subtract one more standard deviation, add one more standard deviation. Now we're between 15 and 35, so 95% of the data is between 15 and 35. And then 99.7% of the data is between 10 and 40. Alrighty? The standard normal distribution. So we can take any normal distribution and transform it into a standard normal distribution using the one little calculation that you see down there, that z equals x minus mu over sigma. Okay, the standard normal distribution is a normal distribution of standardized values called z-scores. A z-score measures the number of standard deviations, and x value is above or below the mean. So z, the standard normal distribution z, is the normal distribution with a mean of 0 and a standard deviation of 1. Alrighty, so let's see this thing in action as we go down here and talk about Jacob. So Jacob scored a 32 on the ACT, while Will scored an 1850 on the SAT. So they tell us the ACT, these are both college entrance exams. And they tell us the ACT is normally distributed with a mean of 21, standard deviation of 5.5. And the SAT is normally distributed with a mean of 1490 and a standard deviation of 300. This is during those several years where the SAT was out of 2400. It's back to being out of 1600 now. All right, so who scored better? To answer this, we're going to calculate the z-score for both. So we got Jacob over here. His z-score would be 32, because that's his x value, minus 21. That's the mean, mu, over the standard deviation 5.5, sigma. So he is 2 standard deviations above the mean. So that's pretty darn good. Will still did really well with an 1850. So if we calculate Will's standard deviation, it's a 1.2. So it looks like Jacob is more above the mean than Will. So Jacob scored better. That's the conclusion we reach. So this standard normal distribution gives us a way to compare how people did in 2 totally different normal distributions, which is pretty cool. Okay, so our graphing calculator has what's called normal CDF in the Distra menu. That's what we're going to use to calculate probabilities. All right, so your calculator will ask for a lower value and upper value, the mean, and the standard deviation. So it looks like normal CDF, lower value, comma, upper value, comma, mean, comma, standard deviation. So here we go. The final exam scores in a stats class were normally distributed with a mean of 63. Your mean's going to be way better than that, I can tell. And a standard deviation of 5. Find each of the following probabilities for a randomly selected student. So probability that the student gets higher than 65. So let's go through the steps on the calculator, all right? So we're going to go over here to our calculator, and we're going to go to second Distra, which is above VARS. And then we want to go to normal CDF. And then it's going to give you a lower value. So since you think about the curve, right? You think about the curve, x greater than 65 right here, right? So this is going to go from 65 out to infinity. All right, your calculator can't have infinity as an input, so therefore we use this 1E99. So let's look at the keystrokes to get that, okay? So here we go. I got normal CDF. The lower is going to be 65. The upper is going to be 1 times 10 to the 99. So that's 1, and then times 10 to the, see the little EE that's above the comma button? We're going to hit that. So second comma. So 1E99. That is scientific notation for 1 times 10 to the 99 power. That's pretty much infinity in our land. We have no idea what that number is. It's a giant number. Pretty much infinity. All right? So the mean is 63 and the standard deviation is 5. So I'll go down here. I input the mean is 63. The standard deviation is 5. Then I hit paste. Got to hit it one more time. And there's our probability. So probability, a student gets greater than a 65.3446. All right. What's the probability? This student gets lower than a 68. So suppose you got one of the old school TI-83s, right? So now we can edit this. We can go second entry and actually edit this. And I want to go less than a number this time. So I'm going to go -1, second E99, comma, and I think it's less than a 68, was it? Less than a 68. So 60, the 63 and the 5 are going to stay the same. So I'm going to go second, insert, and put an 8 there. So that's x less than 68. So now hit enter, and you come up with a 0.8413. So 84.13% of students get below a 68. All right, not going to happen in this class. Y'all do better than that. All right. The last one, probability is between 58 and 68. Right there, you do the same thing. Normal CDF, lower bound 58, upper bound 68 with the 63 and 5. You should notice 5 is the standard deviation. One standard deviation lower than 63 was 58. One standard deviation above 63 was 68. Guess what our percentage was? 68.27%, rounding to 68%. That's exactly what we expected to happen. Alrighty? So, moving on. Remember to pause videos as you're going through if I go too fast, or watch it on a slower speed. It's funny to listen to me talk slower. A picture helps visualize what you're trying to find. Remember, the probabilities for continuous distributions are found with areas. The area under the entire curve is 1. So probability that x is between negative infinity and infinity is going to be 1 for a normal distribution. All right. Another type of problem you'll see is if you're given the probability and asked to find the x value. We're going to use what's called inverse norm. So we're going to use the area, and I'm going to use the area to the left. The newer calculators let you choose left tail, right tail, or middle. I am always going to use left area because that's what the old school calculators do. They're going to use the left tail area. Alrighty, so here we go. A personal computer is used for office work and a myriad of other things. Suppose the mean hours a PC is used per day on entertainment is 2 hours with a standard deviation of 0.5 hours. 10% of households use their PC for entertainment at least how many hours? So we're being asked the probability x is greater than some value is 0.10. So these, I am going to tell you that you should definitely draw these. All right? It's a greater than, so it's a right tail area right here. So I draw it, and I find the area on the right tail is 0.10. So remembering that the whole area under the curve adds up to 1, that's going to mean the area between negative infinity and that x value has to be, right, 1 minus 0.1 or 0.9. Okay? So we're going to have to use the 0.9 when we do inverse norm. You're going to see on these new calculators that I am just going to leave it anchored on left tail. All right, so I'm going to use left tail all the time. Feel free to use right tail or middle if you want. So here we go. Inverse norm. The area is 0.9 to the left. The mean was 2, and the standard deviation is 0.5. So then I paste a Rooney, you leaving it on left tail, and I get 2.64. So what can we conclude then? 2.64 hours is going to be, that is 90% of people will use their computers for 2.64 hours or less. So 10% of people use their computers 2.64 hours or more for entertainment. 95th percentile. What 95th percentile means is that 5% of the data is going to be in the right tail for 95th percentile. If it asks for 43rd percentile, we'd basically 43% of the data is going to be in the left tail. But 95th percentile, that is going to mean that 5% of the data is above it, so 95% is below it. So when I inverse norm it, I'm going to use 95% right there with a mean of 2, standard deviation of 0.5, so 2.82. So 95% of people use their computer for entertainment less than 2.82 hours. 5% of the people for greater than. What is the first quartile? Remember, first quartile means 25% of the data. So we inverse norm it with 0.25. So the interpretation is 25% use PCs less than 1.66 hours for entertainment. So that is chapter 6 in a nutshell. Remember, as you're going through your homework, remember to use the the chapter Q&As. Those are my old Zoom lessons that show you how to do some of these MyOpen math problems. Ask me in office hours. Ask me in class if it's an in-class section. Okay, there it is, y'all. Have a great day. We'll see you in chapter 7.